A bipartite graph is a graph that can be colored using only two colors in such a way that no two connected nodes share the same color. What's fascinating is that the question of whether a graph is bipartite can be answered only by using linear algebra, where one primarily focuses on matrices. And a famous matrix in graph theory is the adjacency matrix of a graph, which represents the connections between nodes and which can indeed tell you whether a graph is bipartite. But how should this be possible? Matrices have their own multiplication rule, and they serve in some sense as functions for vectors. When a matrix is multiplied with a vector, it can rotate or stretch the vector in various ways. For this specific matrix, we can analyze how it affects every vector in two-dimensional space. Here we notice that some vectors will retain their direction and will only be stretched by a specific factor. These stretching factors are exactly what we call the eigenvalues of a matrix, and when we calculate them for our previous bipartite graph's adjacency matrix, we will notice that they are symmetric around 0. And what's now very interesting is that a graph is indeed bipartite if and only if the eigenvalues of its adjacency matrix are symmetric around 0. And note here that bipartite graphs are not the only graphs where the eigenvalues of their adjacency matrices behave interestingly.